get it done before the break. So, binomial theorem investigation. So we're going to put in some binomials. Notice how these are binomials. That's where the word comes from in the theorem. And we are raising them to different exponents. Okay? We've done x plus y to the fourth and x plus y to the fifth for you. I want you to fill in these. Should be pretty fast. Okay? So what's x plus y to the 0? Hopefully that doesn't take you too long. Yes, 1. Write it down. These aren't trick questions. They're just pretty easy. What happens if you write this down? What happens to Ms. McKay?
Punches you.
Well, no, I read wrong. Gray hair, remember?
Oh, sorry.
Yeah. Missing a term.
Like, my guess is you actually probably see that more often than
you do. Oh, yeah, sorry. That's wrong too.
Even us gray hair.
Yeah. Sorry. Now we got it. So to get x plus y cubed, just take this and multiply by x plus y.
Oh, I didn't realize that there's... Oh, I guess that would make sense then.
Okay, so you can kind of do that in your head. So x squared times x is x cubed, x squared times y is x squared y, and then you get an x squared y from this, so it's 3x squared y. And you get 2xy squared plus xy squared is 3xy squared, and then the last term. So I'm just going to go back and erase this. Okay, so kind of interesting if you look closely. Coefficients here. So that's just a 1. Coefficients here are 1. Are 1 and 1. Coefficients here are 1, 2, and 1. Coefficients here are 1, 3, 3, and 1. So I'm running out of space. Next ones are 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. Hopefully you kind of remember back to yesterday with Pascal's triangle. So all the coefficients are the same as the entries in Pascal's triangle. Okay? So what would change those coefficients, though, remember, is if you had a coefficient within each term. But if you just have x and y, or, I don't know, p and q, or l and m, just variables, then those coefficients are directly from Pascal's triangle. Okay? So, that. So it says, examine the above expansions and answer the following. The number of terms of the expansion. So take a look. So if we are raising this to the exponent 3, we have 4 terms. Exponent 4, we have 5 terms. Exponent 5, we have 6 terms. So the number of terms is 1 more than the exponent of the power. So if you're raising it to the exponent 4, you'll have 5 terms when you expand it out. Right, Josh? No. Expansion of x plus y to the 8th, then we'll have 9 terms. Okay, so we might just ask you some properties like that. We're not going to ask you to expand necessarily all of these binomials, but how many terms? What's a particular term, etc. So in order for an expansion to have a middle term, so So notice here we have 9 terms in this one. Would we have one middle term? Yes, if it's an odd number, you'll have a middle. It's like calculating the median, right, in stats. So if there's an odd number, the median is the middle one. So what do we know about the exponent? It's even. If the exponent was 7, we would have 8 terms. So there would be 2 middle numbers. There wouldn't be exactly 1. So in order for the expansion to have a middle term, so A means 1, middle term, the exponent has to be even. Okay? The degree of each term is the sum of the exponents of the variables. What is the relationship between the exponent of the binomial and the degree of each term? So take a look at this one. This exponent here is 5. The degree of this term is 5, 5, 5, 5, 5, 5. Right? Every term will have a degree the same as the exponent on that expansion, that binomial. Okay? If both of these are variables, right? If we had a number there, then instead of y, we would have a number in there, so the degree would then be extended, right? But if they're both just x and y, or as I said, p and q, or whatever that is, the degree will be the same. So what is the relationship? So that's going to be the same. Oh, I guess it's going to be fast. These will be the same. Okay, so going from left to right, as you move from term to term, what happens to the exponent of x? So it's 5 there, 4, 3, 2, 1, 0. 4, 3, 2, 1, 0. So it's decreasing. Okay, and that is, x is the first term in the binomial, right? If x was the second term in the binomial, then it would be the opposite. It would be what our y is. So that's our next one. Going from left to right, as you move from term to term, what happens to the exponent of y? Well, there isn't a y, so it's 0. 1, 2, 3, 4, 5. Okay. So that's in particular for this binomial expansion of x plus y. Obviously, you switch the variables, and switch the answers there. So, it says write the next 4 rows of Pascal's triangle. So just do that quickly. Right? Remember, you add up the diagonals of the previous row. So 4, right? Okay, so what is the connection between Pascal's triangle and the expansion? So you can kind of compare it a little bit here. So this was an exponent of 0, the value. Then here, these are the coefficients when our exponent was 1. These are the coefficients when our exponent was 2, and so on. Okay, so what is the connection between Pascal's triangle and the expansion? So this is row 1, right? This is row 2. So the coefficients of x plus y to the n are the terms in which row? So here, if we have, for example, x plus y squared, that's in the 3rd row. So in row n plus 1, one more than that exponent.
See, this is why they should be just go with the row zero. Then everything like that. Row zero. This way? Yeah, because then it's like, oh, zero, zero, zero. Oh, probably because they don't want to deal with people saying zero row.
Yeah. So use your new knowledge to state the coefficients of the terms in, that's a 6, x plus y to the 6, okay? So that's the exponent. They're going to be the terms then in the 7th row, which we've done, right? So 1, 2, 3, 4, 5, 6, 7. Okay, so that's going to be 1, 6, 15, 20, 15, 6. Also, another kind of pattern that you can think about. So notice how the exponent is 6. Always the first and last are 1s, but the coefficient there, the coefficient of the second term is 6. So notice here when it was squared, so it's in the 3rd row, x plus y squared, the second coefficient is 2. When it was cubed, the second coefficient is 3. It moves to the 4th. So that's kind of another little hint there. Okay. So now to write the expansion. So remember what we talked about there in terms of the degree of each term, and we're dealing with x plus y, right? So the first will be x to the 6. I don't need to show the 1, right? That's understood to be a 1. So that's going to be x to the 6. Sorry. Okay, x to the 6. Plus 6, and then we go down 1 for x and up 1 for y, right? Because this is really y to the 0. Then plus 15, down the exponent, up an exponent.
Nope.
Oh, yeah, squared, sorry. And then this will be cubed. So notice how it's a quick way to check. The degree has to be 6 in each of these. Now, if you had this, say we didn't have the triangle written out, but you had the expansion of x to the x plus y to the 6. Now we're asked for x plus y to the 7. Then just look at the coefficients of the previous, right? We know the first one has to be coefficient of 1, and it'll be x to the 7. Okay? Then 1 plus 6 is 7. And we go down 1 for x, 1 for y. Then 6 plus 15 is 21. Okay, so I mean, you can go back up here because we did it, but maybe we won't give that to you. We're going to learn another way. But from here, based on what we know, this would be the easiest. Okay, so 21 plus 35. I'll go down here. Plus 35 again. Plus 21.
Yeah, it gets a little ridiculous after a while.
Yeah. Okay, so then that's why comparing it to Pascal's triangle with your combination notation will make your life, especially as that exponent gets bigger and bigger, and say you're only asked for a particular term, it's going to make it a lot easier for you. So there's Pascal's triangle in the using the combination notation. Okay, what's the relationship between these and the coefficients of the expansion? So same deal. The coefficients in x plus y to n, or in row n plus 1, right? So, again, we're still calling this row 0, right? So if we're expanding, say, to the exponent 4, then that's 0, 1, 2, 3, 4. So this value here, so it's in row n plus 1. In terms of the first, I'm just going to write this down. First term in that row will be n. This exponent on the binomial will be that value there. Right? So those will match up. Okay, so without looking at Pascal's triangle then, so here, this is x plus y to the 8. So our first term, or just the coefficients I guess we need. So that exponent will be your n value in your combination notation. Okay. And here's how you check. You put 8 there, 2, 0. That's just going to be 1. That's not really a way of checking. But if we then do 8c1, the value of 8c1 is 8. And remember that pattern that we came up with was if the exponent was 8 on the binomial, the second coefficient would be 8 as well. And that's going to be 8. And we have 8c2, 8c3, 8c4, 8c5, 8c6, 8c7, 8c8. Okay, so then the expansion, well, 8c0 is 1. It's going to be x to the 8. That's going to be 8. X to the 7y. Then 8c2 would be 8 times 7 divided by 2. 4 times 7 is 28. X squared, no. X to the 6, y squared. 8c3, so 8 times 7 times 6, right out by 3 factorial, so 8 times 7 is 56. And that would be x to the 5th, y cubed. And then 8c4, that's going to be, what is, I'm trying to do it in my head differently in practice. So 8 times 7 times 6 times 5 divided by 8 times 7 times 6 times 5 divided by 4 factorial. 4 times 3 times 2. So there's your 6 twice. So that's 70. Then you don't need to do any calculations, right? Because it's symmetrical. So now we'll go back from there. The next will be 56 x cubed y to the 5th plus 28 x squared y to the 6th plus 8 x y to the 7th plus y to the 8th. Okay, so note that the third term in this expansion is 8, so those match up. The r value is 2. Remember, term number, your r is 1 less than it. X to the 6 is so that exponent on x is the difference between 8 and 2. And the exponent on y is the same as that r. Okay. 6 terms, so that's going to be 5 there. 8 minus 5 is 3. 5 is the exponent of y. So fourth term here, so the exponent is 10, so we'll have 10c. Fourth term means this will be a 3. Okay. Then we'll have x. Well, 10 minus 3 is 7. Okay, and think about it. The fourth term, so we would have x to the 10, x to the 9, x to the 8, x to the 7. y, fourth term would be same as that. It's going to be cubed because it's going to be y to the 0, y to the 1, 2, 3. Okay? Then you can actually calculate the value of that. 10C3 is 10 times 9 times 8 over 3 times 2. So that goes in 4, that goes in 3, so 120. Seventh term in this expansion, so the exponent is 13, okay? Then seventh term means r is 6. X to the 13 minus 6 is 7. Okay. Y to the 6. Remember these, if they're variables in both, they're going to add up to that exponent. I'm going to use my calculator for this one. Okay, 1,716. Your coefficient. All right, so now we're going to come up with the very last formula on your formula sheet. Okay? So we're almost done the course. So the last formula on your formula sheet is what we're coming up with right now. Okay, so write a, listen please, write a formula for the k plus 1 term of x plus y to the n. This is called the general term and it's denoted by t, k plus 1. Okay, so it kind of gives it away, but whatever. Let's go through it ourselves. So that's n. So we'll have NC.
There are a couple questions before that.
Oh, are there?
Yeah, that kind of like allow you to determine Oh yeah, I can say that. Oh yeah. There we go.
Okay, so here, if we're finding, so say we're finding the 5th term, then k would be 4, right? So if we're finding the 5th term, you subtract 1 from 5 is 4. That means k would actually be that r value, okay, because of that k plus 1. Then we have x here, and remember the exponent is going to be n minus k. And then we have y, and the exponent will be k. So you can see if you add those together to get the degree, you get n, which is the degree of each term. Are you on the phone? Seriously? Who are you talking to? Really? Maybe not. Can you say bye? I'll talk to you later at 2:03. Bye. See ya. Oh my Lord.
This was my class.
Good thing I'm not doing report cards today. Although we're not allowed to comment on your behavior on report cards anymore.
That could mean that you missed mark part.
Yeah.
No more.
All right. Okay, question 6. Use your knowledge to write the expansion of that. Notice the difference. You don't have x's and y's. which is fine, who cares, right? Whether it's a, b, or x, or y, but we have coefficients, and it's subtracting. So you have to be a little bit careful. So we're writing the whole expansion, simplify the terms, hint, let x equal 2a and y equals negative 3b, okay? I don't really show that. I just substitute it right away. So this is 4, right? So 4c0. We can even put all the c's and leave space in between. Then I use brackets and I put that first term. That's where x was, right? That's my first term. The exponent on that is going to be 4, right? 4 minus 0 is 4. Then I put brackets for my second term and I include the sign. So if it's subtracting, I make it negative in there. Put it in brackets and that's going to be 0. Like for that first term, you don't have to show the negative 3b to the 0 because obviously it has a value of 1. But I'm kind of just getting in the pattern of writing these out. So then it'll be 4c1 2a cubed. 4 minus 1 is 3. Negative 3b to the 1. Again, you don't have to show a 1 because anything to exponent 1 stays the same. But I'm kind of using the formula. So I'm writing big, so I'll go to the next line, keep going here. Then 4c2 2a squared negative 3b squared plus 4c3 2a to the 1 negative 3b cubed. Again, before I do any simplifying, the sum of the exponents on the brackets is always 4. Right? So it's a bit of a way of checking. And then my last term is 4c4, 2a to the 0, negative 3b. Okay, I need a little bit more space because I'm writing big. Now you need to simplify. Okay? So that's just going to be a 1. And then that's 2 to the 4th is 16a to the 4th. So I don't even need brackets, right? I hear a voice.
What's going on?
Hello, let me pause. Okay, so next one. I know it's hard to focus. Okay, so 4c1 is 4, 2a cubed. I figure out what that is. Just copy it out. If you can do it and simplify everything at once, go for it. I'm just doing it in a couple of steps. 2 times 3 is 6. Okay. Oh, I don't need that. Oh, okay. So then I go through and get rid of the brackets. So what's that? 12 times 8 is 96, so minus. Plus. But he literally and then
It's not like you just like people doing a quiz and something. It's not like they're trying to be caught.
okay, let's not argue. Okay, so yes, did I make a mistake? Which term? 4c to 0 is 1.
the last day.
It's the last day. Okay, so that expansion had, let's focus here, I know it's hard, it had a subtraction, it had different coefficients. Take a look at the next one. Notice how in this one is 3x squared plus 1 over x. You don't often show expansions like that, but you might have it. All to the exponent 8. One of the terms is ax to the 7. Determine the value of a. So a is the coefficient. They're really wanting you to find the coefficient of the term that is the x to the 7th term. So these all had two variables. This just has one. Okay, and so you might think, oh, x to the 7th, that's going to be the first term because it's raised to the, oh no, that would be the second term because it's raised to the exponent 8. But remember, there's x's in both of those, so it's not going to be the second term. So what you want to think about is that general term here, okay? So we know 8, the exponent there is 8, c, and then we'll just use a k for right now. Then we would have 3x squared to the 8 minus k, 1 over x to the k. Has to equal ax to the 7th. So all I did was use that formula there, which is on your formula sheet. Fill in what you know. You know the exponent, and you know the first term and the second term. You know that you have to try to find a. So for right now, I don't actually care what a is. I want to know, I don't care what this number is. I don't care what the 3 does. I just care about the x's, right? So from there, I'm going to say, so dealing with the x's, I'm going to go, okay, well, x squared to the 8 minus k is x to the 16 minus 2k. This is x to the negative 1. So that's the same as x to the negative k. So I'm just looking at the x parts of it. I'll go back and get the coefficient, but for right now, just the x's. To simplify this again, multiplying powers of the same base, add the exponents. Right, and I'm just going to look at the exponent parts. Okay? You can show it as x to the that equals x to the 7 if you want, but this plus this has to equal 7, because we're multiplying powers with the same base. So that's 16 minus 3k equals 7. What's that? Negative 9. K equals 3. If you get a negative for k, you did something wrong. All right, so now we want to get the coefficient. So now we really only care about the number part, but I actually put it all back in just to confirm that I get x to the 7, right? So now I take k equals 3 and I do this again, but with 3 instead of k. So I'll do this. So, okay, sorry. Flipping, but we have 8c3, and then that was 30x squared to the 5, and then positive 1 over x to the 3. Okay, and then I want to say, I'm not going to make it equal to ax to the 7th here. I want to make sure I get a the 7th. So that's what, 8 times 7 times 6. 8 and 7 is 56. What's that? 81 times 3 is 243. Everything okay over there? Okay, so then 56 times 243. Okay, we are almost done. One more question. Is the last question.
You still have like
Well, for today, it's the last question. Okay, so this is another common type of question. So we've got an expansion. One of the terms is the constant term. Determine the value of it. Okay, anytime you're doing these, I do not want to see the expansion entirely until you get that. That would be 13 terms that you're trying to figure out. Okay, that is not efficient, and that's why we give you the formula for a term. It says one of the terms is a constant term. So what does that mean? The exponent on a variable is exponent would be 0 on a variable, right? Then we wouldn't have the variable. Anything to raise the exponent 0 is 1. Okay, so this will only happen to get a constant term if you have a variable in one term and a constant in the other. But we don't. We have variables here. That's because we will get a constant, perhaps, because the variable's in the denominator, right? So sometimes they'll obviously counteract each other. So we want kind of set it up like before. Now it's 12. So I'm going to do it like this, but now I'm going to have x to the 0 here. So 12ck, not Calvin Klein, but ck. And then first term. Oh, I shouldn't have an equal, sorry.
not yet.
And I'm going to change this x squared in the denominator to x to the negative 2. And then that's going to be to the k, and we want this to be some coefficient x to the 0. So again, I only care about the x's first. So I'm just going to look at the x's here, x to the 12 minus k. Then that's going to be x to the negative 2k equals x to the 0. So I'm just looking at this part and this part and this part. So that's going to be 12 minus k minus 2k equals 0. Yep. No, I'm looking at the exponent here.
Just think about taking log x and
Right, multiplying powers are the same base. We're adding them here. Okay, and they'll make it equal. So this is exponents. Okay, so now we know k has to be 4. So we put that back in. So that's going to be 12c4. And then 2x. Can we just listen for 2 more minutes, please? 2x to the 8. Negative 3 over, oh, actually, I'll use the negative exponent here. Negative 3x to the negative 2 to the 4. Okay, so k goes in there, so that'll make that 8. That's your k. Now, find the value of each of those. So 12. Four. Remind me what 2 is. 6. Okay, this is how you check. This needs to multiply the powers. X to the 8 times x to the negative 8 is x to the 0, which is 1, right? So you know you want the constant term, you can't have any x's left. So then it's just going to be 495 times 256 times 81 big number. Okay. And that is the last question that we're going to do together for the year 2021.